Today topic is parity bit. To append binary bits to secure that the total count of ones in the original data is even bit or odd bit. So we are going for a parity bit, which is called as a check bit also, which is added to a block of data for error detection purpose. It is used to validate the integrity of the data. The value of a parity bit is assigned either 0 or 1. That makes the number of ones in the message block either even or odd depending upon the type of parity. Parity check is suitable for single bit error detection only. So here we are going for the types of parity. This comes under a even parity bit and then odd parity bit. Even parity means the total number of ones counted is to be odd in the count including the extra bit added also. That is comes under a odd bit parity. And then even bit parity, the total number of ones counted is to be even in the count including the extra bit added. It is comes under a even parity bit. So in even parity, the total number of bits in the message is made only even. In odd parity, the total number of bits in the message is made only the odd here. So this is the example for even parity and odd parity. So in case of even parity, so we are going for a sender's end while creating a frame. The sender counts the number of ones in it, and they can add the parity bit in the following way. So first one, in case of even parity, if number of ones is even, parity bit value is 0. If number of ones is odd, parity bit value is 1. In case of odd parity, if number of ones is odd, parity bit value is 0, and if the number of ones is even, parity bit value is 1. This will comes under the sender side, and then we are going for a receiver side. Receiver side means on receiving a frame, the receiver counts the number of ones in it. In case of even parity check, if the count of 1 is even, the frame is accepted, otherwise it is rejected. In case of odd parity check, if the count of 1 is odd, the frame is accepted, otherwise it is rejected. For example, suppose the sender wants to send the data 1001101, using a even parity check method means it will add the parity bit, and they are going to add a 0 only there, because of we are having already even number of 4 ones. That's why we are having a 0 only. And then now we are going to see what are the types of error detection. So first thing is LRC, longitudinal redundancy check, and then VRC, vertical redundancy check, and then CRC means cyclic redundancy check, and then checksum. In here we are having a checksum. So first thing we are going to see is longitudinal redundancy check. So a block of bit is organized in rows and columns. It is called also a two-dimensional parity check. The parity bit is calculated for each column and sent along with the data is called as a LRC. And then block of parity act as redundant bits. So we can see how we are going to use the LRC also here. So we are having a original data here, and then in this original data, in order to see, we are going to see here. So in this place we are going to see we are having a only one odd number here, means we are adding a 0 here. Sorry, we are adding a 1 here. If we are having a 1 2 3 3 ones, this is also comes under the odd, so we are adding a 1 here, and then only one is present here, we are adding a 1 here, and then here we are having a 3 1, so we are having a we are adding 1 here, there is no 1, so we are adding a 0 here, and then we are having 2 means even we are having a even number of 1 means we need to add a 0, and then we are having a 3 1 here, we are adding a only 1, and then we are having a 4 1 here, so it comes under even, so we are adding a 0. So now it is called as a LRC. So while we are sending the message, we are going to add this LRC in our first place. So this is the sender side and this is the receiver side. So by adding the LRC in our original data, we can able to send the LRC concept here. So and then we are going to see advantages and performance of LRC is LRC increases detecting burst errors. So if two bits in one data unit are damaged and two bits in exactly the same position in another data unit are also damaged, the LRC checker will not detect an error. So it is one of the performance we are using in a LRC. And then disadvantage, and I already told you, in same place there is a direction, so the LRC can't able to find out the error. So it is a disadvantage. Next one, we are going for a vertical redundancy check. So it is also called as a parity check only. So vertical redundancy check means in order to, we are going to append the 1 and 0 by the help of odd one and even one only. So in vertical redundancy check, we are going for this method. It includes even parity and odd parity also. Even parity means the total number of one is in data is to be even, and odd parity means the total number of ones is data is to be odd. For example, if the source wants to transmit data unit 11001111 using even parity to the destination, the source will have to pass through even parity generator only. So they can be generate once, that is parity generator will count number of ones in data unit and will add parity bit. In the example, we are going to number of ones is in data unit is 5 means parity generator appends a parity bit 1 to the data unit, making the total number of 1 is even, that is 6, which is clear from the 1. So data along with parity bit is then transmitted across the network. So the data will be transmitted at the destination. The data is passed to parity checker and the destination. So number of ones in the data is counted by a parity checker, and the number of one counts to be ordered or in odd number, it will be failed. So if you are added in a even number, it will be a correct message. So what is the advantage? So this is the example we are going to see here. So here we are having a 1 2 3 4 5, so we are having a odd number of 1, so that we are going to add a 1 only here. After the even parity generator counts the 1 only, they are going to set as a VRC. After that only it will be received by a receiver side, and then the parity checker will be count the ones here, and then they are going to even parity means it will accept the data, which there is a odd parity means they will reject the data. So we are having a disadvantage in VRC also. So VRC can detect, first we can say advantage, VRC can detect all single bit error. It can also detect burst errors, but only in those cases the number of bits changed is odd, that is 1 3 5 x 7, that's all. And then VRC is simple to implement and can be easily incorporated into different communication protocol and system. So it is efficient in terms of computational complexity and memory requirements. VRC can help improve the reliability of data transmission and reduce the likelihood of data correction or loss due to errors. VRC can be combined with other error detection and correction techniques to improve all the overall error handling capabilities of a system. So now we are going for a disadvantage. So VRC is not capable of correcting errors, only detecting the errors only. The error detection is that not to able to detect burst error also. So in the original data, we are going to sending double one double zero 111 means after adding VRC, data unit that will be transmitted is double one double zero double one double one. Suppose on the way two bits are corrupted, the whole part will be corrupted. So VRC is not capable of correcting errors, only detecting them. This means that which can identify errors, but it cannot fix them. VRC is not suitable for applications that require high level of error detection and correction, such as mission critical system or safety critical application. VRC is limited in its ability to detect and correct errors in large blocks of data, as the probability of error increases with the size of data block. So VLC requires additional overhead bits. It to be added to the data stream, which can increase the bandwidth and storage requirements of the system also. So this is comes under a VRC. And then performance means it can detect single bit error, and then it can detect burst error only if the number of error is odd, and then sender is sending the transmission data, and then there is a zero means it will reject the data. And the next one we are going for a CRC.